Article 402 or 401 does not specify anything about low-voltage fixtures. The regulation that fixture wiring shall not be used as branch circuit conductors applies to low-voltage fixtures as well. This means the low-voltage fixture must come equipped with a whip, or the wiring must be home from the fixture back to the transformer without a splice. If the wiring is installed in conduit, you can use XHHW or RHW wiring. Let's delve into the specifics. The reason why fixture wiring should not be used as branch circuit conductors stems from safety and code compliance. Branch circuit conductors are typically sized and protected based on the load they serve, and they must meet specific requirements for insulation, ampacity, and overcurrent protection. Fixture wiring, on the other hand, is often smaller gauge and may not be rated for the same conditions as branch circuit conductors. Using fixture wiring as branch circuit conductors could lead to overheating, insulation breakdown, and potentially a fire hazard. The requirement for a whip or home wiring back to the transformer ensures that the connection between the fixture and the power source is made with appropriately rated conductors and properly installed connections. A whip is a short length of flexible conduit containing conductors that are suitable for the voltage and current requirements of the fixture. It provides a safe and reliable connection between the fixture and the branch circuit. Home wiring refers to running the conductors directly from the fixture back to the transformer without any intermediate splices or connections. This eliminates the risk of faulty connections and ensures that the entire circuit is properly rated for the load. When installing wiring in conduit, XHHW and RHW conductors are commonly used due to their excellent insulation properties and resistance to moisture and heat. XHHW stands for cross-linked polyethylene high heat resistant water resistant. RHW stands for rubber high heat resistant water resistant. These conductors are suitable for use in wet and dry locations and can withstand higher temperatures than some other types of insulation. Using XHHW or RHW conductors in conduit provides an additional layer of protection for the wiring, shielding it from physical damage and environmental factors. Choice between XHHW and RHW conductors often depends on local codes and specific application requirements. Always consult the applicable electrical codes and regulations to ensure that the wiring installation meets all safety and compliance requirements. Now let's consider some additional factors related to low-voltage lighting systems. Low-voltage lighting systems typically operate at 12 volts or 24 volts, which is lower than the standard 120 volts or 277 volts used in many other lighting applications. Low-voltage lighting offers several advantages, including increased safety, lower energy consumption, and greater flexibility in fixture design. However, low-voltage lighting systems also have some unique considerations when it comes to wiring and installation. Due to the lower voltage, low-voltage circuits typically require larger gauge conductors to carry the same amount of power as higher voltage circuits. This is because the current is inversely proportional to the voltage for a given power level. The larger gauge conductors help to minimize voltage drop and ensure that the fixtures receive the proper voltage for optimal performance. When installing low-voltage lighting systems, it is important to carefully select the appropriate transformer to match the voltage and power requirements of the fixtures. The transformer should be sized to handle the total load of all the fixtures connected to it, with some additional capacity for future expansion. The transformer should also be installed in a location that is accessible for maintenance and inspection, and it should be protected from moisture and other environmental factors. In addition to the transformer, low-voltage lighting systems often require the use of specialized connectors and wiring methods to ensure reliable and safe connections. These connectors and wiring methods are designed to handle the higher currents and lower voltages associated with low-voltage circuits. It is important to follow the manufacturer's instructions carefully when installing these connectors and wiring methods to avoid any potential problems. Furthermore, it is crucial to properly ground the low-voltage lighting system to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The grounding conductor should be sized according to the applicable electrical codes and regulations, and it should be connected to a grounding electrode system that is properly installed and maintained. When working with electrical systems, it is always essential to prioritize safety. Always disconnect the power before working on any electrical circuits, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. In summary, when dealing with low-voltage fixtures, remember that the fixture wiring should not be used as branch circuit conductors. You must either use a whip or a home run the wiring back to the transformer without a splice. When installing wiring in conduit, XHHW or RHW conductors are acceptable choices. Always consult the applicable electrical codes and regulations to ensure that the wiring installation meets all safety and compliance requirements. These regulations and best practices are in place to ensure the safe and reliable operation of electrical systems, protecting people and property from potential hazards. Remember to prioritize safety, use appropriate materials and methods, and consult with qualified professionals when needed. Also, be aware of the specific requirements of Article 411 of the National Electrical Code, which covers lighting systems operating at 30 volts or less. This article provides additional guidance on the installation and wiring of low-voltage lighting systems, including requirements for transformers, overcurrent protection, and grounding. One important consideration in low-voltage lighting systems is voltage drop. Because of the lower voltage, even a small amount of resistance in the wiring can cause a significant voltage drop at the fixture. This can result in dimming, flickering, or even complete failure of the fixture. To minimize voltage drop, it is important to use appropriately sized conductors and to keep the wiring runs as short as possible. Voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance. By calculating the voltage drop for a particular wiring run, you can determine whether the conductor size is adequate. If the voltage drop is too high, you will need to increase the conductor size or shorten the wiring run. Another important consideration is the type of transformer used in the low-voltage lighting system. There are two main types of transformers used in low-voltage lighting systems: electronic transformers and magnetic transformers. Electronic transformers are typically smaller, lighter, and more efficient than magnetic transformers. However, they can also be more sensitive to voltage fluctuations and may not be compatible with all types of low-voltage fixtures. Magnetic transformers are generally more robust and reliable than electronic transformers, but they are also larger, heavier, and less efficient. The choice between electronic and magnetic transformers depends on the specific application requirements and the type of low-voltage fixtures being used. When selecting a transformer, it is important to consider the total load of all the fixtures connected to it. A transformer should be sized to handle the total load with some additional capacity for future expansion. It is also important to choose a transformer that is compatible with the voltage and frequency of the power supply. In addition to the transformer, low-voltage lighting systems often require the use of dimmers to control the light output. There are many different types of dimmers available for low-voltage lighting systems, including rotary dimmers, slide dimmers, and digital dimmers. The choice of dimmer depends on the specific application requirements and the type of low-voltage fixtures being used. Some dimmers are designed to work with electronic transformers, while others are designed to work with magnetic transformers. It is important to choose a dimmer that is compatible with the transformer being used in the system. When installing low-voltage lighting systems, it is important to follow all applicable electrical codes and regulations. These codes and regulations are in place to ensure the safe and reliable operation of electrical systems. It is also important to use qualified electricians to perform the work. Qualified electricians have the knowledge and experience to install low-voltage lighting systems safely and correctly. In conclusion, low-voltage lighting systems offer many advantages, including increased safety, lower energy consumption, and greater flexibility in fixture design. However, they also have some unique considerations when it comes to wiring and installation. By following the guidelines outlined above, you can ensure that your low voltage lighting system is installed safely and correctly.